We have reached the finish line of acid-base reactions and equilibrium and all of that. And question 15 puts a lot of this together. We're thinking about our definitions of strong and weak. We're thinking about it in terms of a reaction, maybe in terms of a titration. We're thinking about what a buffer is. We're thinking about the amount of acid to conjugate base, like our predominant species and all of those things. We're remembering that there's stoichiometry while acknowledging that after the stoichiometry, there's often equilibrium. Putting it all together, which makes this a great question for an AP problem. Maybe a multi-part, but even this just kind of can be all one together. So how do I make a buffer with these things? And what's super important is earlier we answered, well, I have to have HF and NAF. Well, it says I have HF. You can't say, well, I'm going to also get its conjugate base. If it tells you to make a buffer, but tells you are limited in the chemicals you have, you can't go into your imaginary stockroom and grab a chemical that they're not saying you have. You can't, we said that ammonia and ammonium chloride, well, you can't say, well, so then I would also get its conjugate. Where is that coming from? I've got 5 chemicals here. We can only use those 5. So the options kind of depend on what you wanted your pH. You don't have to do both of these. One or the other is correct, but showing both of them is important just to remember. So I used kind of the same numbers and the same color codes and all of that I used in the notes, but with some more specific values here. So if I wanted to make a buffer out of ammonia, I would need some ammonia, but I also need, as I just said, ammonium chloride. I don't have it. How can I make it? Well, HCl has chloride in it, and if I do the reaction right, in the right mole ratio, the HCl will react with the ammonia to make ammonium chloride. So here it says use 100 milliliters of this, 50 milliliters of that. I did moles here, thinking about these as all being 1 molar solutions, 0.1 molar, excuse me. You could also just say 150 and all of that, but I wanted to focus in terms of moles to remind us of that. And really, this works with any volume. So we could use high enough volumes. We could use a liter, we could use half a liter, we could use 1,000 liters and 500 liters. All of those work as long as it's a 2 to 1 to make an ideal buffer. If it's close to 2 to 1, it'll make a buffer, but it won't be ideal. So the key here is I have 0.01 and 0.05. This is like all reactions of acids with bases. It is stoichiometry. It goes to completion. So we don't have to get a Ka, a Kb, all of those things while we're doing this part. That's why the 2 to 1 is important, because all of the thing that I have less of, and in this case, it'll be the strong. I don't want any strongs in there. All of that strong will go away. And if I did it right, then half of the weak will go away. Then we'll think, well, I have half as much weak base. Why is that good? Because the other half has turned into its conjugate acid, into weak acid. After doing that, I have an equal amount of weak base and its conjugate acid floating around in water. The HCl is gone, so we are good to go. The pKa on this, we needed to change our pKb to a pKa, because if we want our pH, that's important. I didn't show the math because we've done that so many times, and we've done it so many times recently that we have that value, but that would give me a buffer that has a pH that's kind of high because I'm using a base. I'm not going to read you all these words down here, but the same works with a weak acid and a strong base. Same 2 to 1 ratio, same stoichiometry, same idea, same limiting excess, same amount of product. All of those things are true. But now we have just a weak acid with its conjugate base. We do the negative log of the pH of the pKa of the Ka gives us our pH. And that's what we know there. So Hayden's here just in time to say good job, because you finished the acid-based videos and notes and practice problems. Awesome job.